Okay, this is RStudio. So let me show you part of your homework this week is to do a lab. Okay, what you're going to have to do is you're going to have to search for R. Okay, you just type in R, and the very first thing that comes up, the R project for statistical computing. Okay. So you're going to download and install R. So you click this, and then you come over here where it says download packages, okay, and you click CRAN, okay. CRAN is the place where you download your packages. Like that. And then it lists all of these places all around the world. We actually have a server here at UCLA, and you can just click the UCLA one. That will probably give you the lowest latency, but whatever. You click any of these will work. Okay, that's the wonder of the internet. You can download anything from around the world. All right, and then depending on your computer, you would choose Linux, Mac, or Windows. And then you install the program, download the package, and you install it. Okay, simple enough, right? So that will be R. Okay, you can do all of the labs and exercises with R alone. Right? There's something called RStudio, which is an interface that sits on top of R. Okay, it just adds a few buttons and a few things that make your life a little bit easier. Okay, which is nice. So you can install that. I recommend it. You don't have to. Okay, if you have a slow computer, RStudio uses more resources, and so maybe your computer won't like it as much. But it's not bad. Again, you just go to Google, type in RStudio. First thing you'll find is that RStudio, and then you click Download RStudio. Okay, click that button, or you can scroll down wherever you want. Right? Download, and then choose the desktop version. Okay. Pick the free one. Okay. They have a commercial license. There's no need. Okay. Just pick the free one. Okay. All of this is free, by the way. All right. Which is free.
So we should download both?
I recommend. Okay. You definitely need to download R. Okay. RStudio will not work if you don't download R. Okay. So you first have to download R, and then optionally you can download and install RStudio on top of R. Okay. And I recommend both. I recommend both. Okay. Unless your computer is like more than 5 years old or something. Okay. And if that's the case, maybe you have to use R by itself. But try it. Just try RStudio, see if it works. And if it works, great. Okay, and when you start up RStudio, it'll probably look like this. Okay? I blew up my text over here so it's easier for you guys to see. When you load it up, the text will be smaller. Okay? So R has a command line interface. Okay, I don't know if you had to deal with a command line interface, but basically, you type you're going to do a lot of typing here. Okay? And you type, and then your answers show up. In this week's homework, okay, or homework 3, let's say for the lab 1, and it includes stuff here, okay. And I just have a couple pages, brief introduction to R and the binomial and normal distributions and things like that, okay. So you can click these, and they give you commands like stuff like that. Okay, that should help you work through this this week's lab, the first couple parts are easy, and then the last part is hard. And has anyone done computer programming or anything like that? Okay. Who has never done computer? Oh, okay. All right. If this is your first time dealing with computer programming or something like that, okay, you're going to run into a lot of frustration. Okay. And then, you know, I've been doing this for a while, so I'm used to it. Okay. But when you first start out, it's very frustrating. Okay, because the computer is so particular and stupid. Okay. It only knows how to do things if you do things exactly the way it's expecting you to do things, okay? You have parentheses in the wrong spot. You put a comma in the wrong spot. You put something in the wrong spot, it's going to give you an error, okay? So when you're learning, just type everything out, and then if you get an error, check your line exactly to see if there's just anything that you might have typed in wrong, okay? You will be tempted to just copy and paste commands from somewhere else, okay? Don't do that, all right? If you copy and paste, you're not going to learn anything. I mean, maybe you don't want to learn anything. But if you copy and paste, you're not going to learn anything. So just type things out manually, okay? And deal with the frustration. It'll get better, okay? And you'll learn, like, oh, I got to pay attention to these commas and the spaces and things like that, okay? So actually the spaces probably, well, I mean, sometimes they matter, but, all right, okay. So let's deal with this, all right. Command line interface just means we're going to type things in here, okay? So we can start off with something simple. If I hit 2 plus 3 and I hit enter, it says bracket 1, 5, okay? This little carrot, thank you, means R is ready for your input, okay? If you give it something that takes a while, if it's thinking, so if you give it a difficult command and it takes a while to think, this will not appear and it will say, that means it's not ready for you to give input, okay? But if you see it, it means it's ready for input. So I type in 2 plus 3, 2 plus 3 is 5, okay? And it spits out 5. This bracket 1 means the first part of your answer is 5, okay? R is designed for statistical input, okay? Meaning it handles lots of information. So we can handle many numbers at once. And so if I have an answer with many parts, it'll say, you know, the first part of your answer is 5, and then, you know, it might say like the 10th part. So I mean, we can just do basic things like this. 4 times 3 is 12, and that's not exciting. I can say there's a command called C, concatenate, that just says put these numbers together. I can say put the numbers 1, 5, 7, and 8 together, and it says, okay, there are the numbers 1, 5, 7, and 8. And then I could say, okay, well, take the numbers, you can hit the up arrow on the keyboard, and that gives you the last thing that you typed in. Okay? I could say, okay, take those numbers 1, 5, 7, and 8, and add 4 to each of those things. Okay? And I hit enter, and it says, okay, if I add 4 to each of those, I get 4, 9, 11, and 12. Okay? Let's do that, and that's that, okay? But we didn't install R, so we can do 2 plus 3 and 5 times whatever, okay? I'm going to hit Control L. This just clears the stuff, and so my commands show up at the top. Control L is clear the thing. It doesn't. Okay. Here we can use built-in probability functions here. Okay. So one probability function is the binomial distribution. And for that we will use dbinom. Okay. Dbinom is a function that allows us to calculate probabilities for the binomial distribution. Okay. There's actually, the base is binom, and D stands for density. Okay. And this answers the question, if I flip a coin 30 times, what's the probability that it lands heads 23 times? Okay. To answer that, right, the number I'm looking for is 23, and I'm going to flip the coin 30 times, and the probability that it lands heads is 0.5. So I put in the numbers like this. And I hit enter. And this tells me that the probability of getting exactly 23 heads out of 30 coin flips is 0.00189596. Okay. We could calculate this ourselves using our calculators, right? Or, I mean, we could use this, we could say choose 30, choose 23 times 0.5 raised to the 23 times 0.5 raised to the 7. Okay. Are we in agreement that that's should give us the same answer? I really hope it does. Okay. And it does. Okay. Is that okay? All right. And but we didn't want, for this last problem we did, we wanted to get 23, 24, 25, all the way up to 30, right? So it still would be a pain in the butt to type in dbinom. I could use the up arrow and I could do dbinom 24 and get this, okay? But there's shorthand. I can write 23 through 30, okay? And 23 colon 30 is essentially writing 23, 24, 25, 26, 27, 28, 29, and 30, okay? So these two are exactly the same, okay? R sees, when it sees this, it sees this, okay? And so this is the amazing thing about R, is I can take a bunch of numbers as an input and throw it into a function like dbinom. So I could say dbinom.
What is dbinom?
Dbinom is calculate the binomial probability. Okay, so if you're writing stuff in the notes, you're writing commands and things like that, you should also write like an annotation. So maybe I'll do that for you guys. Okay, so dbinom 2330.5. This is what is the probability of getting 23 successes through 30 trials? So anyway, that's what dbinom is, okay? It's the binomial probability.
That's what that
dbinom 2330.5 is doing 30 choose 23, 0.5 to the 23, 0.5 to the 7. Okay. So anyway, I'm going to do dbinom 23 through 30. You guys see that? dbinom 23 through 30. This is going to plug in 23, 24, 25, all the way up to 30 into the function d binom. What's it going to spit out? A bunch of numbers, okay? This, okay, are you guys okay reading things in scientific notation? Okay, so when you see e minus 03, that means take this number and multiply it by 10 to the negative 3, okay? Or basically move the decimal over 3 places to the left, okay? So we see that this corresponds to the 23, and that is 0.01895. We see that number right there, okay? And this number corresponds to the 24, and that matches that number, okay? Just, again, the decimal's moved over 4 places to the left, okay? And so, and this corresponds to the 25, the 26, the 27, 28, 29, and 30, okay? So we plugged in 8 numbers by using 23:30, and then it spits out all 8 numbers, okay? So that's kind of neat, right? Okay, but that wasn't the answer we were looking for. We wanted to know what's the total probability of getting 23 or more heads. So we want to add all of these up. We want to take all 8 numbers and add them up, okay? So again, you know, when you type in 23 through 30, R sees this, or R sees that, okay? When you type this in, R evaluates it as this, okay? And we can say, take all these numbers and add them up. And so what I'm going to do is I'm going to use the function sum, okay? What sum does is I'm going to just put sum around the output of d binom this, okay? And so first, what R does is it evaluates what's on the inside first. It's going to get these 8 numbers. It's going to see those 8 numbers, and then it's going to run the function sum, which then adds all those 8 numbers together. And what does it give us? It gives us 0.0026114. I think when we did our approximation, we got 0.0031, which is a little off. Yes?
What did you say the bracket 1 means?
So bracket 1 says that, okay, so my answer has 8 parts to it. This says the first part of your answer is this, the third part of your answer is this, the 5th part, and the 7th part is this.
Okay.
Okay, because there's 1, 2, 3, 4, 5, 6, 7, 8.
Oh.
Okay, so if you have a whole bunch of lines, it allows you to keep kind of track of where you are. Is that okay? Here, let me okay, so using sum and d binom, I can get this answer, okay? There is the related function that goes with d binom. D binom allows you to calculate entries for each answer, okay? 23, 24, 25. Or there's p binom, okay? P binom says everything, that number and everything small. So if I do, let's start off with let's do some easy examples, okay? So if I said woman is pregnant with twins, okay, probability of boy is 0.5 for each twin, okay? I can say, what is probability of one girl? Okay. So how would I do this with d binom? I would say d binom one girl, 2 children, probability of a girl is 0.5. Okay? What's the probability of getting 0 girls? 0.25. And what's the probability of getting 2 girls? 0.2. Okay? Is that okay? Let me show you what p binom does. Okay? P binom 0 to 0.5. P binom is what's the probability of getting this number or less. So P binom 0 to 0.5 is what's the probability of getting 0 girls or less. That's going to be 0.25. What's the probability? P binom 1 would give me what? Probability of 1 or less, so that answer should be
0.75.
0.75, exactly. And P binom 2 should give me 1, because that's 2 or less.
So p-denim is like this, like either 2 or less.
Yeah, so it's this number or less. That's what P binom says, okay? 0 or less, 1 or less, 2 or less, okay? So we get, it's kind of like a cumulative thing, all right? So do we understand the difference between D binom and P binom, okay? All right, so what if I wanted to answer this question of what's the probability of getting 23 successes or more if we do 30 trials? Can we answer that using P binom? 1 minus P binom
26.
22.
Or 22.
Okay. So let's do 30 trials, 0.5 probability. What is probability of 23 or more successes? Okay, this is equal to 1 minus P binom 22, 30, 0.5. And just to compare that with this. Is this okay? Or is this just like dark magic? Okay, so then there is, so that's the binomial distribution. We also have the normal distribution, okay? The normal distribution, the functions you're going to use are going to be P norm and Q norm. Okay, P norm and Q norm are inverses. There is a D norm, but that's the density, and it's kind of like what's the probability of getting an exact number, but it's not really that interpretation either. So we won't worry about it. Okay, so P norm is if I draw a line here, how much is shaded to the left? So if I say P norm 0, it should spit out
0.5.
0.5, okay? If I type in P norm 1, it should spit out
0.84.
0.84, okay? 0.84134447. Okay, we see that this is actually even more precise or more accurate than the normal table that we have in our book. Okay? And we can say things like, we can specify a mean and a standard deviation. So I could say, what percentage of women are shorter than 60 inches if the mean is 64.5 and the standard deviation is 3? Okay? So I could say P norm 60, 64.5, and 3. It's expecting numbers in this order, the number you're looking for, and then these are optional. If you leave them out, it assumes mean of 0 and standard deviation of 1, like a z-score. Okay? Or you could specify a mean and standard deviation, and it gives that. Okay? Or if you didn't, you could just type in P norm negative 1.5 because that's what this is equal to. Oh, we get that, right?
So P norm is to the left of this.
P P norm is everything to the left, okay? And if you want what's to the right, what do you do?
Just go to the next.
Q norm?
No, you do 1 minus P norm, okay? 1 minus P norm. So what is Q norm? Okay, so if we want area to the, yeah, so area to the right, subtract 1. So we do 1 minus P norm. Okay, what is Q norm? Q norm gives you the z-score that corresponds to this area. Okay, so if I say Q norm 0.5, it will tell me the z-score that's going to give me 0.5 is
0.
0. Area to the left. So what z-score will give me an area to the left of 0.5? 0. Okay. So what is the z-score that's going to give me area to the left of 90%? Go ahead, look in your table, see what you get, and we'll compare it to what R spits out. P norm is, you put in the z-score, what's the area to the left?
So for P norm you put, you already know Z. You put the Z.
You put in the z-score, or if you don't know the z-score, you can plug in the mean and the standard deviation. Yeah, so we're expecting something around 1.28, okay, and we get 1.2815552. So that's the usage of P norm and Q norm. Is this feeling kind of okay? All right. All right. The last bit in your lab, and this is the least favorite part. Okay, is importing some data. Okay, and you're gonna have to. This part you can copy and paste into your thing, but you're gonna have to import a data set, okay? Now there's a few ways you can do this. Okay, if you copy and paste this, it's going to download, it should download a CSV file. Okay. Well, I'll check to see if the website's broken. It's the World Health. Okay, there it goes. Alright. Data.text.csv. Okay. So there's a few ways. You can import data, alright, using RStudio, using import data set. And then and you'd say, okay. And you have to open this thing up, okay? There's a few functions, read.table, read.csv. The import data set in RStudio does some nice things also. I'm going to just do a quick okay, so I was able to import my data here. I just used a couple of short commands here, and and what this is it's data from the World Health Organization, and it's just mean blood pressure of I think men and women from different countries around the world. Okay, so they went to Afghanistan, and they looked at the mean blood pressure, 126.4. Okay, and then you go to Armenia, and the mean blood pressure is 135.2, etc., etc., etc. Okay. And they make the confidence interval. Basically, we're just going to use this column, So when you import a data set, whatever you call it, here I called it data. Okay, you might call it blood pressure or something. There's different, basically the different headings are the different columns of the data. Okay, and here I have 386 observations on 12 variables. Okay, and if I want to get any one particular heading, I would reference that as data $, and I would type in indicator. Okay, and I would hit enter. Alright, and then it spits all of this out. Okay, and they all say mean systolic blood pressure, age, standardized estimate, and that's because if you look at the data, that's what it says. Okay, so probably the one of interest to us is this column numeric. Okay, so I can say data $numeric. It's case sensitive. Okay, and then it spits out all of these numbers. Okay, and apparently I have some NA entries in there. So there were countries where we did not get the values for them. But we can use R to calculate the means of these things, okay? Or I can use so I could say find the mean of data $numeric, okay? And it's gonna say NA. Why does it say NA? Well, what's going on is that there's unknown entries here, okay? And it says, well, there's unknown entries, I can't give you a mean, right? It's like saying, oh, there's 3 kids in my family. The oldest, one of them is 20 years old and another one is 22 years old. I forget how old the other kid is. What's the average age of the kids? You can't tell me because you don't know how old the third kid is, okay? So you can say, well, of the 2 kids you gave me, the average is 21, but I don't know the third. So that's what it basically R is saying. It says, I don't know what this is, so I don't know the average. So you could just say, well, give me the average of the ones that we do have, okay? And so if ever there's something you want to do and you're not sure, you can always just do question mark what you're trying to do mean, and it pulls up the help file. And you see there's this argument called na.remove, and it says indicates whether NAs should be stripped before computation proceeds. And that's what we want to do. So we're going to say na.rm equals true. And it does that and it removes the NAs. Okay. If you get stuck, whatever you're trying to do, just go to Google and say, how do I do this in R? How do I blah 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 in R? And then there's probably going to be somebody who had the same question, and there's going to be some answer, okay? In the beginning, all the information out there is going to feel overwhelming, okay? It's going to feel overwhelming, but that's okay. There's a challenge part to your lab, and that is, it's going to require you to do some subsetting, okay? And challenge because it's hard. So you're going to have to go on the internet, you're going to have to say, how do I subset, or how do I, limit things in my data to this and that. Okay? Try it out, do the best. If you get stuck, that's okay. Do what you can and try it. It's going to be frustrating at first because the first time you're dealing with a computer program or a programming language, it always sucks. But it's not meant to torture you, so if you get stuck, you can always post questions on the Facebook. Okay, we'll see you guys next week. Good luck.